There's an old Bruce Springsteen song. Let's see if you can figure out which one it is. What are machines good for? Absolutely a lot of things. Whoa, whoa, whoa. What are machines good for? All right. Maybe you didn't recognize the song. All right. So I'm going to draw something that looks like a cloud. And you say, what's that? Well, clouds are kind of what we call amorphous, meaning they're kind of like, we're not sure what's behind this cloud, but I'm going to say it's a machine. You say, well, what kind of machine? I don't know. Is this a lever? Is this a wheel and axle? Is this a pulley? I don't know, because it doesn't matter. So in math class, you might, never mind, let's leave math out of this. Okay, so all machines have basically an input side. This is what you're going to do. Remember from the car jack is if I want my car jack to raise the car, then I've got to put force through a distance on the input side of that car jack. And there's always going to be an output side. Now, it's not always super easy to tell what's the input side, what's the output side. But I mean, in general, okay, what are you doing to the machine? Where are you grabbing it? Where are you having to exert force? All right, let's suppose that there's a lever here sticking out of this machine. And on this side, there is a platform. And I'm not getting too fancy here, but basically there's this big, super heavy box. And the goal is for you to lift it through some distance d. Oh, that is not going to work. How about this darker green? Yes. Okay, so it's going to be some distance. And you're going to need to exert the colors are getting a little red. I don't know. Well, the box is red. I don't want... Okay, whatever. Okay, and you're going to need to raise that against gravity. So there's going to be a force on the output side. So we're just going to call that F out. Just get used to that. This is the output forcing machine. And this is the distance that the machine is going to push through. So guess what on the input side is you're going to have to stick your little hand on this thing. And you're going to have to pull down. Well, let's make it a smaller arrow because actually I'd like to make it much smaller. Okay, and then we're going to call this the input side. And this is the input side, so this is the force you're going to have to just imagine you're like pulling your hand on that thing and you're lowering it. So you're exerting some force and it's going to end up down here. And so that's going to be, the D end is going to be like that much. This is so you're going to exert a force. Let's see, where's your hand? There's your hand. Force through a distance. And while you're doing that, you're going to see this thing raising up. Okay? Now, you're going to have to do a certain amount of work in. So you're going to do work in, and we're just going to start calling that work in just because we like to not write that much. And when you're doing this input work, this force through a distance, you're going to see that this little platform is going up and it's exerting a force on the box through some distance, and that's going to be the work that comes out. But of course, we're going to use the same idea, capital W for work, and then we use a little subscript out, say work out. So what are machines good for? Whoa! A lot of things, but I'll tell you one thing they're never good for. They never, ever, ever give you more work out than you put in. Ever. Never. Ever. This is kind of like the law of the machines. Work out. The work that comes out of your machine will never, ever, ever So if you were to make this claim, this is wrong. This is what will never ever happen. You will, so I'm going to make sure you never ever 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 happen. You will never get more work out of a machine. So then what are machines good for? Whoa. I'll tell you what they're good for is machines are force magnifiers. That's what you do, is you can get more force out of a machine than you put in. In fact, that's the most typical. 98% of all machines are designed so that if you, let's just throw out a number here. I'm just making up a number here. So suppose that you exert a force here of 100 newtons. That's like 20 pounds of force. So not a huge amount of force. If you exert an input force of 100 newtons, it's quite common. It all depends on the machine. This is what we're going to be analyzing here, but it's quite common 98% of the time, but don't quote me on that, but I'm just saying the vast majority of the time, almost all the time, your machine is going to do, so basically you do 100, and this guy, this force here could easily be 1,000 newtons. It's not hard to get a machine that can give you 10 times more force than you put in. In fact, many simple machines, you get hundreds and thousands of times more force out than you put in. That's what machines are good for. Whoa! They are force magnifiers. Okay, so we want to quantify this idea. Okay, well, this idea that you can get more force out. So force out can be much greater than you put in. Okay, next slide, please. All right, so let's kind of do this more formally. This idea that machines can give you more force out than you put in, and we'll talk about that other 2% where you actually get less force. Don't worry about that. For now, let's just assume that all machines are designed so that you get more force out than you put in. So this idea of getting more force out than you put in has a name. It's called mechanical advantage. And that's a lot of words, so we're going to abbreviate that. MA for mechanical advantage. So suppose I have a machine Okay, get used to these little cloud machines because I don't care what kind of machine. And suppose that if I put in, and I'm not going to draw the lever anymore, but if on the input side, so if on the input side you put in 10 newtons in, and what comes out of your machine is a whole lot more force. I'm not going to quite make it to scale here, meaning I'm just going to, okay, you're going to get more force, let's just, in this example, and you're going to get 100 newtons out. Is that the same as my, oh, well. Okay, we see that the force that comes out is 100 newtons when you only put in 10 newtons. So what is the mechanical advantage? We want to quantify that. So MA, the mechanical advantage of any particular machine, is the ratio of the force that comes out of your machine divided by the force that you have to put in. So it's force out over force in. So in this example, EG means example, what is our mechanical advantage? Our mechanical advantage is, well, we have 100 newtons coming out of our machine, and we have 10 newtons coming in thanks to you, and 100 divided by 10 is 10, and the units cancel, so it's just a number, it's a ratio. So in this particular machine, it has a mechanical advantage of 10. Now let's just apply that. Now let's just end the video here. We'll do another video.